Number 20. Graph the function using the techniques of shifting, compressing, or stretching, and reflections. Identify any intercepts on the graph, state the domain, and based on the graph, find the range. Okay? So they give us a parent function, which is x cubed, that is being multiplied by some negative constant, and there is a positive number being added to the x values, and there's a negative number being added to the y values. Okay? So there's 4 things that we know about this function, about the transformations. 1, there's going to be a reflection across the x-axis because all of our outputs are being multiplied by a negative number. 2, there's going to be a vertical stretch because all of our outputs are being multiplied by a number that has an absolute value that's greater than 1. 3, there's going to be a horizontal shift to the left. And I'll explain why that happens later. And 4, there's going to be a downward vertical shift. And that's because there's a negative number being added to all of our y values. Let's take a look at the behavior of a parabola. We know that it has a root at the origin, meaning when we set the function equal to 0, x is equal to 0. But what happens when we add a positive number to our x values, making the function x plus 1 squared? Well, our root is equal to negative 1. So our graph that was once centered at the origin has been shifted to the left and now is centered at negative 1. And that's why we have a horizontal shift to the left when there's a positive number being added to our x values. So our input and output, x and y, are going to be transformed to x plus 2, negative 2, y minus 8. So let's go ahead and graph this function using our techniques. And we'll start by graphing the parent function. So we know that the parent function x cubed looks something like that. All right. And after a reflection across the x-axis, the positive x-axis will look like this. The negative x-axis will look like this. Okay. And after a vertical stretch, we'll have something that looks like this. All right. After a horizontal shift to the left, we have a graph that looks like this. And after a vertical shift, negative 8 units, we have a graph that looks something like this. Okay? So that's our graph. And I'm going to erase all of this extra stuff and just sketch a picture of our graph all by itself. Okay, so now that we have a picture of our graph, let's go ahead and identify our intercepts.